Hello, Proviso students, and welcome to Notes on Simplifying Radicals. So, as we work through these notes, anytime you need to stop the video to write something down, please do so. And then just play to continue on. All right. The learning objective is quite simple. It is that I will be able to simplify radical expressions. Now, we're talking about radicals. You're probably not quite sure the definition of that with regards to mathematics. So, here's the vocabulary. A radical is the inverse or opposite operation of applying an exponent. So if you need to write that down, hit pause. All right. You've been doing radical operations when you take the square root of an expression. Take the square root of, let's say, for example, oops. All right. Let's say we have 9 is the square of 3, which means that if I take 3 squared, I get 9. The inverse of that is the square root of 9 is 3. So now we're saying the square root of some number, 9, is that number we're squaring to give us 9. Another way to look at this is, let's say I got 5 squared. I'm going to get some value. When I do the inverse of that, that is, I'm trying to figure out if I have 25, what number is of that? What number squared will give me 25? So this is squaring a value, like 5 squared gives us value 25. This is the inverse of squaring. This is taking the square root to identify the value of what's going to go in the box, which would be 5. So square root 25, or radical 25, will equal 5. So let's look at example 1. As you're going through, you want to write down definitions, vocabulary, and the examples. So you want to jot them down, copy them down, so when you start working on problem sets, you have the information you need. So example number 1, find radical 36. So what that means is we want to know what the square root of 36 is. Well, that's going to equal. What that really is saying is what number squared gives me 36. And that would be 6. So radical 36 is 6. And you could put it in a calculator and get that. But really, conceptually what's going on is this portion right here. Try and find out what we're squaring to get us 36. All right, that's a good example too. Now this one is we're just going to have square root of 81. And once again, what that really means is some number squared will be 81. So what is that number? Comes out to be 9. And we're done. These are pretty basic ones. But before we go any further, let's talk about another vocabulary term. The radicand. Nope. The radicand is the number under the radical sign. So we take the radical of the radicand. So let's say we have the square root of 25. This means, literally, the square root of 25. That's what that symbol means. And 25 is the radicand in that expression. So what we're taking the square root of, that's the radicand. Excuse me. And sometimes the radicand, when we take the square root of a number, we get a whole value. Sometimes when we take the square root of a number, we get some decimal number that has repeating decimals without a pattern, and it's not a whole number. And that brings us to another vocabulary term. Perfect squares. And perfect squares are numbers made by squaring whole numbers. All right. So I'm going to make a list. Let's say I have 1 squared. 1 times 1 is 1. Let's say I take 2 squared. 2 times 2 is 4. 3 squared would be 3 times 3, or 9. 4 squared would be 4 times 4, or 16. 5 squared is 5 times 5, or 25. 6 squared would be 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. Oh, 10 squared is 100, and then it goes on forever. These numbers right here are the first 10 perfect squares. Oops. There's the complete list of the first 10. And this list goes on forever. I mean, you could take any whole number and square it and add on to the list. So I could go 1,000 times 1,000 or 1,000 squared. I could go million squared. I could go 5,200,000,000 squared and get another number. Get another perfect squared. So there's an infinite number of perfect squares. These are just the first 10. All right. Perfect squares are very important with regards to simplifying radicals. So let's talk about what it means to simplify a radical. Simplified radicals happen when the radicand which is the number you're taking the square root of. So when that value does not have any perfect square factors. All right. So square root of 36, perfect square, because that gives us 6. Square root of 18 does not, or is approximately equal to 4.246 or 26 and goes on. That's not a whole number. So 18 is not a perfect square. All right. One more thing to talk before we get into the actual problems on how to do this. A lot of this is vocabulary. And the last thing we got to talk about before getting into simplifying radical expressions is the product property of square roots. If I take the square root of 16 and put that in my calculator, I get the square root of 4. If I take the square root of 8 times the square root of 2 in my calculator, I also get 4. So since the square root of 14 equals 4 and radical 8 times radical 2 equals 4, then the square root of 8 times the square root of 2 equals square root of 16. And that brings us to the product property of square roots. Now, I'm not proving it. I'm just showing you how it works. Basically, if I have the square root of a times the square root of b, that will be the same as the square root of a times b. And this is the basis of simplifying radical expressions, applying this property right here. All right, so let's look at some actual examples. Example 3. And once again, you want to be writing this information down because you're going to be asked to fill in this information on a student response form in Teams. All right. So let's say we want to simplify square root of 18 or radical 18. All right. We're going to use, my bad, the ladder method. And if you were factoring out the greatest common factor back in first semester, you'll be a little familiar with the ladder method because we did it in one of our evidences. All right, so this is how it's going to work. Put down your radicand, 18. Now what you want to do is you want to start reducing that. Start with the lowest prime number, 2, if you can. If your radicand's even, 2 goes into any even number. So what I'm going to do is I'm going to put 2 out here, and I'm going to take 18 divided by 2, and that'll give me 9. Bring the 9 down. Now, 2 does not go into 9, so go next value, 3. Can I divide 9 by 3? Yes, I can. And when I do that, 9 divided by 3 is 3. Now, can I divide 3 by 3? Yes, I can. And when I go 3 divided by 3, and I put 1. You want to keep on reducing your radicand using this ladder method until you get to a 1 down here. You got to get to a 1. So now, I got all my factors of 18. 2 times 3 times 3 gives me 18. So what we're trying to do is we're trying to bust some factors out of this the square root GEL. So we're trying to get some factors free, bust them out of this GEL. And the way you could do this is factors can only bust out GEL if they have a partner. And I see 3 as another partner of 3. And partners are pairs, only 2. Not more than 2, just 2. So now, these 3's bust out from the radical GEL. That means that they are